Boundary representation or BREP. Solid model is defined by their enclosing surfaces or boundaries. This technique consists of geometric information about the faces, edges and vertices of an object with the topological data on how these are connected. The solid is defined by the surface bounding the volume as well as inside and outside definition. So as the name suggests, boundary representation is another technique of solid modeling representation scheme. So in boundary representation, we get the information about the face, edge, vertex of an object with all the topological data. Now the solid is defined by the surface bounding the volume as well as inside and outside information. So here the boundary, the outer shell of the object is being given as the information. Now in constructive solid geometry we have seen using basic primitives and Boolean operators we create a solid model. But here it is an extension. Actually boundary representation is an extension of a wireframe model, wherein here the surface information, so actually the extension of a wireframe as well as a surface modeling, which has been used to represent a solid model. Boundary representation or BREP. So BREP data structure. If we see the boundary representation of this solid model, the solid is being taken and we know that it has 1, 2, 3, 4, 5 faces and 1, 2, 3, 4, 5, 6, 7, 8 edges. 1, 2, 3, 4, 5, 6, 7 and 8 edges and 5 vertices. 1, 2, 3, 4 and 5 vertices. Now if we see here, the solid is bounded by 5 faces. Now let us take one face, that is a face 4. The face 4 has edges. Face 4 has edges 1, edges 2 and edges 5. So face 4, it has edge 1, then edge 2 and edge 5. So the face 4 has bounded by 3 edges 1, 2 and 5. Now next if we see the edge 5, let us take the edge 5. Edge 5 has vertex 1 and vertex 2 in connectivity. That is edge 5, it has connectivity with vertex 1 as well as vertex 2. So this is how in boundary representation the data structure is represented. Now all the combinatorial structure or all the connectivity is called the topological information, and all the metric information or all the shape, size, those things, especially the faces, edges, are being shown in the geometrical information. So a boundary representation data structure has both topological information as well as the geometrical information. Now the topological part of the data provides the relationship among its objects such as vertices, edges and faces, similar to be used in wireframe modeling. Now geometric information is usually the equations of the edges and faces. So the geometrical information shows the shape, the edge and face, how it looks, and topological information shows how these edges, vertices and faces are connected. So this is the BREP data structure. Unlike the constructive solid geometry and the inverted tree structure, the data structure of BREP shows the solid. The solid is bounded by different faces. Then each faces is bounded by minimum 3 edges. From this edge, each edge, how it is connected with the different vertex or vertices. So topological and geometrical information and their connectivity and their metric information makes a boundary representation valid. Now, how we can say a boundary representation is valid? For boundary representation to be valid, the validity can be checked by a mathematical evaluation. Now, the evaluation is based on Euler's law, valid for simple polyhedra. So, Euler's relation is V minus E plus F equal to 2, where V stands for the vertices, E stands for the edge, and F stands for the face loops or faces. Now, if you see here a simple polyhedra, we have 1, 2, 3, 4, and 5 vertices. 5 vertices. Now, if you see here the edges 1, 2, 3, 4, 5, 6, 7, and 8 edges. And if you see here 1, 2, 3, 4, and 5 faces. So 5 edges, 5 vertices, 8 edges, and 5 faces. Now, if we apply this in this relation in the Euler's law, we get 5 minus 8 plus 5, that is 2. So, the Euler's relationship is satisfied. Hence, the boundary representation becomes valid. Boundary representation validity. The system must validate the topology of the created solid. BREP has to fulfill certain conditions to disallow self-intersecting and open objects. The conditions include: each edge should adjoin exactly 2 faces and have a vertex at each end. Vertices are geometrically described by point coordinates. At least 3 edges must meet at each vertex. Faces are described by surface equations. The set of faces forms a complete skin of the solid with no missing parts. Each face is bordered by an ordered set of edges forming a closed loop. Faces must only intersect at common edges or vertices. The boundaries of faces do not intersect themselves. So a boundary representation, when you represent a solid through a boundary representation, not only the Euler's law must be satisfied for a valid model, we have the few conditions that is already mentioned here to be satisfied. We can just think of a case of a cube. It is always right. That is, each edge should adjoin to exactly 2 faces and have vertex at each end. Then vertices are geometrically described. Definitely the geometry must be there. Topological information as well as the geometrical information. Then at least 3 edges must meet at each vertex. If you think of a cube, that's right. Then faces are described. Definitely it is described by certain surface equations. Then the set of faces forms a complete skin. These faces must form a complete skin without any missing part. Now each face is bordered by a set of edges forming a closed loop. It's a closed figure. Then faces must only intersect at common edges or vertices. Then the boundaries of faces do not intersect themselves. By seeing the adjoint figure of a boundary representation, these conditions are clearly understood. Some of the features of boundary representation. A solid model is formed by defining the surfaces that form its boundary. The face of a BREP represents an oriented surface. There are 2 sides to the surface: the solid side inside and the void side outside, like in a wireframe. BREP model is created using Euler operation. Many finite element method programs use this method. Allows the interior meshing of the volume to be more easily controlled. BREP is a method to create solid models of physical objects. BREP solid is represented as volume contained in a set of faces. It also contains topological information that defines the relationship between faces. In BREP, a solid is bounded by its surface and has exterior and interior clearly defined. The geometry can be described by its boundaries like vertices, edges, and surfaces. So in a boundary representation model, the object consists of faces, edges, vertices, loops, gens, and body. Now let us see each in detail. Vertex, a unique point in space. This one is a vertex. Now edge, a finite non-self-intersecting space curve bounded by two vertices that are not necessarily distinct. Now this one is an edge with two vertex bounded here. Now in this figure, this portion, this line is shown as the edge. So this body has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. Now next one is a face, finite connected non-self-intersecting region of a closed orientable surface bounded by one or more loops. So this one is a face, it's bounded by the edges. Now loop, a loop defines non-self-intersecting piecewise closed space curve which may be a boundary of a face. So loop is a hole in a face. So if you see in this space there is a hole and that is called as a loop. Now next one is body. An independent solid, sometimes called a shell, has a set of faces that bound a single connected closed volume. A minimum body is a point which topologically has one face, one vertex, and no edges. So this total figure or model is called as a body. Now genus, it is a topological name for the number of handles or through holes in an object. So here it has one through hole, so it has one genus. The total information present in a BREP model is classified into topological and geometric data. The topological part of the data provides a relationship among its objects such as vertices, edges, faces, similar to that used in a wireframe model. Now the geometric information is usually the equations of edges and faces. Advantages and disadvantages of boundary representation. First, let us see the advantages. Boundary representation has the capability to construct unusual shapes that is not possible with the available constructive solid geometry. Boundary representation requires less computational time to reconstruct the image. Valid boundary representations are unambiguous. Boundary representations can be easily converted to wireframe models. Now the disadvantages. Boundary representation requires more storage. It is more prone to validity failure than constructive solid geometry. Model display is limited to planar faces and linear edges. This concept cannot be applied for NC path generation.